Hi guys, this video is an introduction to the use of SQL using SQL Server Management Studio. In a previous video, I went through the installation of SQL Server and SMS, so please feel free to watch that video if you just need instructions on how to do the installation. This is a beginner's guide, so you should know what SQL is, but that's about it. You really don't need any previous experience in SQL to follow along with this video. We're going to create a database, and then we're going to use data manipulation language, query clauses, and just some aggregate functions. There's a lot that I won't cover in this video with regards to SQL. It's a very large topic, and I want to keep it kind of short and to the point, just get you going writing SQL queries. All right, so let's get started. All right, guys, so the first thing we need to do is download a file from this website. The download is free, but they are going to ask you to register. I'll put the link in the description below. So when you're at this website, click on free downloads, and then we're going to want this download here, exe file for Windows. So click on that, and this is where they'll ask you to register. Once you register, you'll have access to that file you can download. And once you download, there will be a Muroc directory created in the root directory of your hard drive. So it should look something like this. And you'll have a directory in there, SQL Server 2019. Click on that. Then go into databases. And this create AP file. That's the one we're going to use to create the database. All right, so the next thing we want to do is open SQL Server Management Studio. And we do that in Windows by typing in the search bar SQL, and it should pop up right there. I run it as an administrator because I've been having issues recently for some reason. When I try to open a query, it won't let me open it unless I'm running it as an administrator. So after that, you'll come to this window, connect to server, and your machine name should be listed right here in the server name. Go ahead and connect to that. And then in the left-hand column, you'll see your server name at the top. And when you open that, you'll have all of these directories. And this databases directory is the one we're interested in. This is where the database will be created. So let's go to that Muroc file. We'll go File, Open, and then Open File, and navigate to wherever that file was created for you. It may be in your downloads. For me, it created this directory, Muroc, and then SQL Server 2019 databases. Double click on that Create AP file, and this SQL script is going to create the database for us. It doesn't matter that we understand all of this. This is beyond the scope of this tutorial. But all we have to do is click on execute up here, and that will create the database for us. Every time you run a script or commands, SQL commands in SQL Server Management Studio, you'll see this window underneath here, and this will give you basically the results of the commands. Okay, so the way to check that the database was successfully created is to refresh this Object Explorer pane here on the left. And we do that by clicking on this circle with the arrow. So you'll see that there's going to be a database added to this list here when we refresh. Open the databases directory, and you see the AP database now there. Now click on the plus sign to the left of AP. And now you see all of these directories, and the one that we're interested in is tables. So click on the plus sign to the left of tables, and now we see these tables here, and these are the tables that we'll be using throughout this tutorial. Those are the ones we're interested in, and those are the ones that we're going to be querying. If you've ever worked with spreadsheets, these tables are similar. It's tabular data structured in rows and columns, where the intersection of a row and a column is a cell. So very similar. And so we're going to be going into these tables and performing queries against these tables. So let's go ahead and open a new query here. We can close this other file. Okay, so the first statement or command that we want to use is use. It's known as a utility command. And we're basically telling SMS what database we want to use. One thing to note is that commands, statements, clauses in SQL by convention are written capitalized. You don't have to write them that way. Your expressions will still work if you don't capitalize your clauses, but it's common to do so. So we would type use and then the name of the database, right? And you'll see that as soon as you start typing, you're given options. So let's go ahead and select AP. And then from here, at this point, if you click on execute, it'll execute all of the commands that are in the file. In this case, we only have one, so we can go ahead and click that. Otherwise, you would just select the part of the file that you want to execute and click execute. You can also execute by clicking F5. So I'm going to do it that way. I'm going to click F5, and then we can see commands completed successfully. So at this point, we're using the AP database. And now we can start to write queries against the database. Okay. So the first clause I want to introduce is select. And select, you're going to be using select for pretty much every SQL query that you write. So with select, we're now telling SMS which table to select. And since we're now using the database AP, we have access to all of the tables in AP. So we say select. We don't tell it the name of the table yet. First, we need to tell it what we want from that table. So typically you're going to be putting in names of columns, but in this case, let's just grab everything from one of these tables. So the way you do that is with a star. So you say select everything, give me everything, and then you say from, and then the name of the table. So let's just pick one, invoices. Okay. And then again, if I were to click execute, it's going to execute use AP and this expression here. So I don't want that. So I'm just going to select everything from invoices and then click F5. And now your results pane shows you all of the data in that table. Okay. Okay. So if we take just a quick second to think about what's happening here, this data is stored in the server and structured according to SQL Server, which is a relational database management system. SQL Server Management Studio is like a window into the data so that we can see the data, and also, it also allows us to manipulate the data, right? They call it a graphic user interface or a GUI. I don't like that term, so I'm not going to use it. But so yeah, it's a user interface. You can interface with the data, but the data itself is stored in the server and structured according to SQL Server. Just wanted to make that point. Okay, so now we can do some simple stuff with this. So say instead of selecting everything from this table, I wanted to just select, say, the invoice number. So I can say select invoice number, again, from invoices. And then again, select only the expression that you're looking to run, and now we see only the invoice number column. All right, so the next couple of queries that I want to introduce are queries not on tables in the database, but on the database itself, and they give me information about the database. Specifically, I want to know what tables are in the database. This AP database, it's easy enough to just look at the Object Explorer and see the tables that are in there, but you may be working with a database that has hundreds or thousands of tables, and that's not very efficient to just scroll through all of those table names. So it's better if you can query the database, get those names, and then filter. Later on, we can filter by certain conditions, and it makes it easier to find a table that you're looking for. So both of these queries are on views. We don't touch on views in this tutorial, but just so you know, that's what they are. So this first one is known as a system catalog view. So same thing, we're just going to select everything from, and this is system.tables. Okay, so you can see in the first column, name, you can see the names of all of the tables in the database, and you can see that they match the ones in the Object Explorer, right? The next one is known as a standard view, and this one is going to be on information. schema, and then we're going to say dot tables. Run that, and now the table names are in this column table name. And going a little bit further with this, say you've identified the table that you're looking to work with, and you want information about the table, not information from the table. So like the values in the table. Specifically, you want the column names or field names. Columns are also known as fields. That can be very helpful because you may have a table that has a lot of columns or fields, and it's very inefficient to scroll lengthwise across the results pane trying to find the column that you're looking for. So the way we do that is we're going to stay with information schema, but we're going to use columns. So we're going to select column name from information schema dot columns. And here I'm going to introduce another clause, and that is the where clause. Where allows you to filter based on given conditions. The condition we're going to use here is the table name. So we're going to say table name equals, and then let's just stay with invoices. Okay, so we're asking for the column names from information schema.columns where the table name is invoices, so from the invoices table. So let's run that, and you can see all of the column names from invoices. We can do the same for another table, so let's just say we want it from vendors, and now we have all the column names from the vendors table. Okay, so we're going to keep working on the invoices table, but before we do that, I want to briefly introduce comments. So comments are a way to add notes or comments into your SQL code. So the way to do that is 2 hyphens, and here we were introducing the where clause here, so let's just add a title where clause. And then if we run both of these lines together, you'll see it doesn't affect the running of this expression in any way. There's another way to add comments, and that's with \**, and then you close it with *\\. And again, this will not affect the running of this expression in any way. Okay. All right, so now let's introduce the next clause, which is order by. So the order by clause allows you to do exactly that, order the results of a query by a particular column. So let's do an example of that. So select everything from invoices, and we're going to order by. Let's find a column that we can work with. Let's just use invoice date. And so invoice date, execute, and now you see that the results of this query are ordered by the invoice date in ascending order. Ascending order is the default order of the order by clause, but you can order by descending with DESC, execute, and now you see the results are ordered by invoice date in descending order. You may see the ascending option written explicitly, so you may see something like this, ASC for ascending, but that's the same as if you didn't have that. So those two expressions will produce the same result. ASC is typically put in there for purpose of clarity. Okay, so the next clause I want to introduce is the top clause. Top allows you to filter by the top number of or percentage of records in a table, or rows in a table. So a row is also known as a record. So let's write select top, and let's grab the first 5 records and pick a couple of fields. So let's just grab vendor ID, invoice total from invoices. And this gives us the top 5 records in the invoices table. We can also add percent to retrieve the top 5% of records. So you can see there was an extra record added down here. That's a top 5%. Now with percent, we can also add an option which is with ties. What with ties does is it will include in the results any values that are equal to the last value in that limit of the percentage. So with ties requires the use of order by because it needs to know which value to look for. So let's do first without ties so we can see what that looks like. So let's return the top 5% of vendor ID invoice total from invoices and order by invoice total. Okay, so we can see that pulls up 6 records, and the last value of invoice total in that grouping is 10. Now, if we add with ties, what we'll see is that now 2 more values were added because these 2 values are equal to the last value in that original grouping. One thing to note is this one particular example could lead to confusion because the vendor ID also matches, but really what SQL is looking for is a match of only the field that is specified in after the order by clause. So it's only really looking for a match to the invoice total value. Okay. Next, I want to introduce some operators. Operators are different from clauses. Clauses structure the overall query. Operators help define the conditions and perform calculations within clauses. So let's take a look at a couple of those. I want to introduce not, or, and in. And I also want to revisit where so that we use it in querying a table and not that standard view. So, and let's go ahead and switch tables. So let's select everything from vendors. And let's just take a look at that. So we can see the vendors table here. So let's go ahead and set a condition for the result where, let's just say vendor city is, and pick a city, Washington. Okay, so these are all the records where the vendor city is Washington. Okay, so we can also use the not operator to find the results where the vendor city is not Washington. And we use the not operator in between where and the condition. So where not vendor city is Washington, and that gives us the results where the vendor city is not Washington. There's a couple different ways to write this. You can also write it with a exclamation mark before the equal sign. That'll give you the same results. I'm not going to go into the details. There's actually even another way of writing this with writing it this way. I'm not going to get into the details of the differences between those. Just for our purposes, just know that they work just the same. They give you the same results. And you can check that in the lower right-hand corner. You can see this returns 117 rows, and the same thing for this, and the same thing for this. They all return the same result. So let's take a look at the OR operator. So let's say you wanted, let's go back to this, and say you wanted the results where the vendor city is Washington or the vendor city is Anaheim. So you add the OR operator in between the two conditions, and you have to specify the vendor city again. So where vendor city is Anaheim. And now these are the results where vendor city is Washington or Anaheim. There's a more succinct way to write this, and that is using the in operator. So let's select everything from vendors. And the way you write this is you say where in, and then you can create a grouping. So you can create a grouping with the conditions you're looking to meet. So actually it's where vendor city in. Now you can create the grouping Washington and Anaheim. Okay, and that creates the same results as the above expression, right? So these two return 7 results. They're both the same. So, and then finally, we can use the not operator in conjunction with in. So we can say not in Washington or Anaheim, right? And so that gives us all of the results where the vendor city is not Washington or Anaheim. Okay. In and not in are actually known as comparison operators. And there are about a dozen or so comparison operators. The well-known greater than, less than, greater than or equal to, less than or equal to, all that stuff. So let's take a look at a couple more of these. So let's write in comparison. And let's select everything from invoices. Okay, that's the invoices table. So now let's select everything from invoices where, and comparison operators normally are used in conjunction with the where clause. There's a couple other contexts where you may see them, but normally you're going to see them in this context. So where, and let's just call it, let's just say invoice total is greater than 100. Okay, so we want all the results where the invoice total is greater than 100, execute, and that's the results there. We can also use the not operator in this context. Let's scroll down a little bit. After the where clause, we can say not, and this will return effectively all of the results where invoice total is less than 100. So these are all the results where invoice total is less than 100, and it would actually return the same result if you were to write it like that. So instead of greater than, you say less than, execute, and it's the same result. Okay. We can also perform arithmetic operations across fields. So for example, here we have invoice total, payment total, and credit total. So imagine the balance due would be the invoice total minus the payment total, minus the credit total. So if we want a result that shows us that, we can do that in the following way. So let's write a title here. So we can say select, and we'll write invoice total minus payment total minus credit total, right? And here we're going to do something known as aliasing. Aliasing is when you explicitly define a result column name. So this is going to be as, so we use the keyword as, balance due, right? And then from invoices. Okay. So let's run that first. So now you can see that the results of this arithmetic operation are returned as balance due, right? And here we can do something else, which is ask for the results where the balance is positive. So say we want to know who has an outstanding balance. So we can specify where invoice total minus payment total minus credit total is greater than 0. So let's run this. And now we have all of the outstanding balances. You may have noticed some of the results have null values. So we can work with those in our queries. So let's introduce null and not null. So let's first select everything from invoices or vendors. And we can see a lot of null values, right? So we can select everything from vendors where the vendor address, let's just pick vendor address 1, and the way you filter for null values is with is null. Execute, and we can see those are the 2 records of vendors that don't have a primary address. You can also work the not operator into this statement, so you can say not null. And this will give you all the vendor addresses, all the vendors that have primary addresses. So let's go back to thinking about the invoices table for a second. So let's pull it up. Let's write select everything from invoices. And let's imagine we want the records where the payment total is between a certain range. So say between 100 and 500. So we can do that with operators between and. And the way that we would write this would be select everything from invoices where payment total is between, and just pick a number between 100 and 500. Execute. So now we see all of the records where the payment total is between 100 and 500, and we can order this by payment total. And we can see it in order. So now we can see it goes from 104 to 450, right in between 100 and 500. Now, let's do something a little bit more tricky. Say we wanted to exclude everything between, say, 200 and 300. So we want everything from 100 to 200 and then from 300 to 500. So you can do conjunctions. So you can say, give me everything where the payment total is between 100 and 500 and where the payment total is not between 200 and, what did we say, 400, 300? Let's just do 300. Okay. Now we see that there's a jump between 175 and 313. So everything between 200 and 300 is excluded. Now I'd like to introduce the keyword distinct. So distinct returns the results of all of the distinct values of whatever it is that you're looking for. So it ensures that the results contain unique rows, eliminating effectively any duplicates. So the way it works is, let's write distinct here, title, and let's go back to the vendors table. So select everything from vendors, and let's look at the vendor city. So we can see the list of cities associated with the vendors. There's multiple vendors for many cities, and so we can see, for example, Fresno is listed multiple times. But let's say you wanted a list of all of the cities that have vendors, but you didn't want to see an instance of that city for each vendor that's in that city. So the way that you would do that would be to write select distinct vendor city from vendors. And now this is a list of all of the distinct or unique cities. And we can see that the default order is ascending. Okay, now let's take a look at aggregate functions. An aggregate function is a function that performs a calculation on a set of values and returns a single value, the result of that calculation. I hope that makes sense. So let's take a look at an example. We'll write a title here, aggregate functions. And the first function I want to take a look at is count. And what we're going to do is we're going to count everything from vendors. And so what this is doing is this is counting all of the rows in vendors. All right, it's counting all of the records. So we see it says 122, and we can confirm that if we select everything from vendors, we see down here there's 122 rows, right? So it's returning that same value. So it's counting everything from vendors. All right. So going back to the example of looking at all of the cities that have vendors in them, say we wanted to count how many cities have vendors in them. Okay, so the way we would do that, select, count, and we say distinct, right? Because we want every distinct instance of each city. And so we say vendor city, count distinct vendor city, and let's give it an alias. Let's say as, and one thing to note here is if we want to give it an alias that has space in between, so here, for example, I want to name it number of cities, we put that in between brackets. So we say number of cities in between brackets, and then we say from vendors, right? All right, it looks like there may be a typo here, distinct. All right, there we go. Okay, so we can see there are 50 cities. Okay. Now let's take a look at the invoice total field before we jump into the next aggregate function. So I want to take a look at invoice total from invoices. And there's a typo there. All right. So we have 114 rows, invoice totals. All right. Let's say we wanted to know what the total of this field is. So what the total for all of the invoice totals is. So we can use an aggregate function, which is sum. So we're asking it to sum invoice total. And let's give it an alias. Let's just call it sum invoice total from invoices. And there it is. So that gives us the sum of that one field. Let's say we wanted to know the minimum value in that field. So we can use aggregate function min, and same thing, invoice total as sum, actually min, invoice total from invoices, right? Okay, so the minimum invoice total in that field is 6. Okay, good. Now, if we wanted to see the maximum value in that field, we can use the aggregate function max, and that gives us this value, 37,966, and this would be max invoice total, right? Okay. Now say we wanted the average. So what is the average invoice total? We can use the aggregate function average. So let's switch it up here. Let's do payment total instead. So let's look at the average payment total. And again, we're going to use two space separated words. So we're going to put them in between brackets. Let's just call this average payment from invoices. All right, so there's our average payment. And we can also do combinations. So say we wanted, let's say, okay, so for example, here we have the average payment given to 4 decimal places. So say we wanted to round it to 2. So we can do that by using a combination of round, aggregate function, and then doing average payment total. And then we indicate how many spaces we want it to round to. So let's just say we want it to 2. And we'll alias this as average payment and from invoices. And so now we have that same number rounded to 2 decimal places. Okay, the next clause I want to introduce is group by. Group by will group rows that have the same value into summary rows. And the simplest example of this is essentially a distinct statement. So let's go back to the vendors table. Say I wanted to see a list of all distinct cities in that table. I could get that using group by selecting vendor city from vendors and then group by vendor city. And that's essentially the same as writing a distinct statement. Distinct vendor city from vendors. So these two will provide the same result. This becomes a little more useful when used with aggregate functions. So say I wanted a column that shows me how many times each city appears in the table. I can do that by querying for the vendor city first, and then an aggregate function. We're going to use here count again, vendor city. So we're going to count vendor city and alias it as, let's just call it vendor city count from vendors, and then just group by vendor city. Okay, and since there are no null values in vendor city, this would be the same as selecting everything. So if we were to write an aggregate function to count everything, and then let's just alias this as instances, say, and everything else is the same. And then group by vendor city. Okay, now say I wanted to filter by a condition. So normally to filter, we would use where, but when we're working with group by, we have to use another clause, which is having. So having, so let's go back to the invoices table and let's just look at that. Let's select everything from invoices. And let's work with invoice total. So select invoice total from invoices. And we can see there are 114 rows down here at the bottom right. So let's group by invoice total. And if there are any repeating values, then that number of rows should be lower. So we see, yeah, so it's 106. So there are some repeating values there. Okay, now if we want to filter by, say, values that are greater than 100, we just use having. So having invoice total greater than 100. And that gives us all of the values greater than 100. All right, now I want to introduce my favorite operator, which is the like operator. Like is pretty powerful. It allows you to search for a pattern within a field, and it's used in conjunction with the where clause. So let's take a look at some examples. So let's go back to the vendors table. Vendors. And let's take a look at vendor city. So in vendor city, there's a recurring pattern. You'll have the name of a city that is 2 words, first word having 3 characters. So Los Angeles, San Francisco, San Diego. So let's say I wanted this table filtered by all of the vendor cities that match that pattern. So the way we do that is select everything from vendors where vendor city is like, and then we'll write the pattern within 2 single quotation marks. And here we use wildcard characters. A wildcard character is something that represents something else. So in this case, we have, again, first word, 3 characters. So we can represent each of those characters with an underscore. So we'll write 3 underscores to represent those characters, and then a space to represent that space. And then anything else, right? We're looking for anything that has a word with 3 letters and then anything else. So we can represent anything else with a %sign. So let's execute that. And now we see the cities that match that pattern. Okay, let's say we wanted to go further and we want anything that begins with San, right? So San Diego, San Francisco, anything. So there's all the cities that begin with San. Now let's say we wanted any city that begins with a particular letter. So the way we do that is we'll write brackets and type that letter in those brackets. So say we wanted all the cities that begin with A. So there's all the cities that begin with A. B, all the cities that begin with B. What if we wanted all the cities that begin with 3 different letters? So say B, F, and D. So we can do it that way. Just write those letters all together. Now let's say we wanted to search for cities that begin with letters within a certain range. So say cities that begin with letters between A and F. We write A-F, and those are all the cities that match that pattern. What else can we do? We can do combinations like, say, underscore, so space, and then letter pattern, and say 2 more spaces. So really here I'm thinking of the city of Fresno. So this is just going to return Fresno. Okay, so as you can see, like is pretty powerful. You can search for all sorts of patterns in there, so that's pretty cool. What else? Another thing that we can do with SQL is concatenate columns. So concatenate columns means putting 2 values from different columns into one column. So taking a look at vendors here, let's say we wanted to combine vendor city and vendor state into one column. So we can do that by selecting vendor city and using the plus sign. Then we add a space and a comma inside 2 single parentheses, and then vendor state, and we'll give it an alias. We'll call this address, and again from vendors. And so there we have the city and the state put together. So that's concatenation. Just a couple of other things I want to introduce before wrapping it up. The first one is working with dates. So SQL has some built-in functions to work with dates. The first is getDate. So getDate gives us today's date. So we can write select getDate, and we can alias this as current date. So that gives us today's date. So this can be helpful in the case that we have other dates to work with in our table. So one example would be, say, the invoices table. The invoices table has an invoice date. So let's say we wanted to know the age of an invoice. So we would need the difference between the invoice date and today's date. So we can get that with another built-in function, which is date difference, written date diff. So the way that we can write that is, let's say we select date diff, and here the syntax is the following. So the first element will be the time frame. So in this case, we want to measure days. So we write day. Then the field, which is invoice date, and then the comparison. So we're comparing to get date, so to today's date, right? And then we can alias that as age from invoices. Okay, so that gives us the age in days of the invoice, of each invoice. So, and we could write hours, for example, here, and that would give us actually hour, and that would give us the age in hours, right? So we want days. So, okay. And the last two clauses I want to talk about are offset and fetch. So offset allows us to skip a determined number of rows in our results, and fetch will limit the number of results that we see. So let's see how that works. Let's select everything from vendors again. And offset needs to be used with order by, so the table needs to be ordered. So let's just order by vendor city again. And we see that the 5th row, the vendor ID is 62, and on the 6th row, the vendor ID is 44, right down here. So let's say we offset by 5. Offset 5 rows. So we should see the first row now with a vendor ID of 44. And that's what we see. Okay, so now let's say we want to limit the results to only 10 rows. So we can do that with fetch. So we can say fetch next 10 rows only. And now we have only those 10 rows. All right, so that does it for this video. Thank you so much for watching if you've made it this far. I hope you found it helpful. And I have other SQL tutorials in the works. They're going to include a little bit more advanced stuff, joins, views, stored procedures, stuff like that. So please subscribe and click the bell so you receive a notification when that comes out. And I'll see you next time.